So what is Arduino? Many people think that Arduino is just Arduino boards. It's true. We do make boards. We do make some boards in collaboration with other partners, like the Arduino 101, which is a board that is our new flagship for education. Has accelerometer, gyroscope, Bluetooth Low Energy, can be Bluetooth host, which almost nobody can, and has a neural network in it. But this actually doesn't mean anything. You know, when you approach a high school, what they want to do is to make really nice science experiments or really nice STEAM experiments in general or art projects or whatever. So you could totally cross this thing here because people don't hear that. But in order to program these boards, you need to have some piece of software that will allow you to program stuff. And we, for now, 12 years have been offering this nice IDE that is made in Java that runs in more or less every computer except for Chromebooks. So we like to say that this IDE is past compatible. So if you have an old classroom with like a bunch of old computers, you can always install this thing offline. You don't need to have internet to run the class, and it works great. But we're also having a future compatible IDE that is HTML5 that is called Arduino Create, and that you can run even on Chromebooks, and that will allow you to program your boards both directly and over the air. On top of that, we have a whole strategy around having documentation online that is publicly available for anybody to learn by themselves about technology, and is completely open. It's Creative Commons 3.0, so you can actually take documentation from here and make your own books. So our hardware that is there is open, our software is open, our documentation is open, and this has created a huge community of users that are very interested in building and sharing with Arduino. I just want to throw one number so you can get to see something very nice. Our website has over 110 million unique visitors a year. So go beat that, people. You know, when somebody wants to build something, they first go to the Arduino website, check it out, and then they make their own thing, which is very relevant. But this is not meaning formal education. So here you can see what people are building with Arduino. This is our community of users from all over the world. This is a test of, or teaser of a lot of things that people are doing using Arduino in general. Yeah. Of course, everybody likes to see robots playing with kids in every possible way. Yeah. So, as I was saying, this is not really formal education for schools. This is a lot of small projects that are being done, but Arduino Education, the department of Arduino I'm working with, is very much concerned with how to bring technology to formal education. I say technology because, I mean, we don't only use Arduino, right? How to bring technology to classrooms all over the world in a program that will go beyond the one experiment. And this is the thing I will talk about today. Arduino is literally used at every school in the world, sorry, at every university in the world. And the thing I'm presenting to you today, which is CTC 101, which is the acronym for Creative Technologies in the Classroom, and 101 comes from the Arduino 101 boards we're using, is trying to bring project-based education in the form of STEAM to the classrooms. We're looking at tackling the problem of how to use technology in the creative process through quick design iterations, doing a lot of interactive projects, using hardware and software, and encouraging people to do group collaboration. So this is not about a geek in a corner sitting alone doing something. It's about kids working together in building projects in teams and sharing them with others. Which are the challenges for this? Well, the challenges are that we live in a world that is anchored in the past. You know, you go around and many schools don't have internet. You go around and many schools have a bunch of really old laptops. And I'm talking by experience because we've been deploying education for now several years. And people are anchoring the idea of that technology is just there for the sake of technology. So you teach kids how to make robots that are going to be doing robotic applications, and not teach the kids how to use technology for their own purpose. Also, we have the problem that teachers don't really have the time to educate themselves. So there's a lot of challenges that we have there. What we're looking at is how to bring collaborative learning, project-based learning in a multidisciplinary way so that people can work together and learn from one another. And this is what we call CTC 101. CTC 101, I have to mention, is kindly done thanks to the help with Intel, which is one of our partners in this project. So what you get with CTC 101 is this box. It weighs about 7 kilos. I cannot translate that to pounds, so somebody should help me out since we're in Britain. That includes everything that you need to run a class with 30 students from zero to the end by building projects in teams. It brings online materials. It has remote support, so you will be getting help from a team of people sitting at the other side of your screen. So when you ask questions, you can get help. And it's distributed through a network of certified partners, people that know what they're talking about throughout the world. I'm going to jump to the next slide because it's a lot of words. So this is our educational goals. If you want to take a picture, I will count until 3, so you can do it. 3, 2, 1. Because I want to show you what is inside. This is what is inside. It's all the materials that you need, all the construction bits that you need, all the electronics that come in this box. And so that you can have 6 simultaneous groups in your class working together. And it includes materials for a total of over 25 projects, actually 26 projects, but it looks a lot better when you say over 25, okay? The idea is that when you're working in class, many times we've seen the situation where a teacher makes one experiment and the students replicate that one experiment, and you have 30 students doing that one experiment. From a logistics point of view, it sounds like it's super easy, it's very smooth, because everybody might have the same issue, and you can correct the same issue all over the place. We don't like to look at creative process in that way. We like people to do different things, be allowed to think differently from one another, and then share their findings with one another. I should say that, before I continue talking, that CTC has been launched in many countries already, actually 3 countries, but it's developed to run in multiple languages. I'm going to leave you with this slide here, and at the end I will give you like real numbers, so you can get a real vision on how many people have been using this so far. What we do is that we put the teacher at the center. This is the key aspect of CTC. So we don't look at having the kid having a great experience while learning. That's going to happen if the teacher feels confident and the teacher has a good time while teaching what he or she is teaching. So we communicate with the teacher and we help this person to teach the class as he or she is learning. So we don't expect the teacher to stop his whole life for a year, go take a master course, and then come back and teach. You know, we want the teacher to be able to continue his professional life in a normal way, take an introduction course, and then start teaching. And as teaching, as they're going to school every day, they learn a little bit more and they bring it to the kids. This works for a full year. So our role here is to support the teachers as they are interacting with the students. And these are all of the resources that we have to help them out. The kit includes enough material to have up to 30 students working in a single class. We recommend to have groups of 3 or 4 students, but some schools, because of the economy of the schooling systems, they might have to run it with more students. There is enough material for each group to make a different project at each step of the process. Our process is made of 5 steps. So first, learn about programming, then digital signals, analog signals, moving parts, robotics, and so on. And the last one is about Bluetooth communication and complex sensors. And every other week, we introduce a new topic, and the teachers learn about this topic, and then they bring it to class, and they experiment with the students, and so on. At each one of those blocks, the students get to make a different project. That's the reason why we have so many different projects, because if I learn about analog technology, my brain will be different from your project, and different from his project, and so on and so forth. So we encourage learning by making. The students, they learn in an embodied process of interacting with the technology, learning how to program, building things. It's extremely hands-on, and they get immediate feedback. This is a key aspect. I guess you all know that when you go to a class, if it takes you 3 months to make a robot move, the students will get desperate in the process. So we designed the process so that every class, the students have a very small success they can bring home. Today, I managed to build this thing. The day after, I managed to make the software for it. The day after, I pitch my project to my classmates. And then I repeat, and so on. So the process happens through collaboration, but also through teaching others. You know, there's a whole educational movement that is based in learning by teaching. It goes back to the 60s. So we are really encouraging the teachers to have the students present their results to the others and explain how they understood things. And we don't expect this to be done just once in the class. We expect this to be done once every other week. So the students, they go into this loop of like, oh, I have a new idea, I make a new project, I present my project, I start a new project, and so on and so forth. That's where the iteration comes in place. I will summarize this whole thing for you. So first, the teachers get some small training. This training can happen online or offline. So we have prepared everything. You go to our website, you get the whole education. It takes about 2 weeks of an online course that you do at your own pace. Then you start teaching. And as you're teaching, you get help from us, both in the forum and online webinars that happen every other week. Then, once you have done this iterative process of learning about different projects, you tell your students, okay, people, now you make your own project. And that is where the ideation project comes in place, and brainstorming, and so on. And you start building your own project, and you work with that for about 8 weeks. And then you present your results in a technology fair. I'm going to show you each one of these steps with video now, so that you can see how things work. First of all, what happens with the interaction during the learning activities? People have an online service. I was going to say an online website, which actually sounds pretty bad, where you have all the documentation included there. This is an example of a project that is for the Block 5, that is about complex sensors and Bluetooth communication. And you see everything comes explained in step-by-step instructions with a video that shows what you can expect from the project, all the code there, explanations about the code, and a guide that guides the students into doing something that goes beyond the exercise. Because we want people to think outside the box, so we encourage them to go beyond what we give them. That's very important. On top of that, as I said, every other week there is a webinar where the teachers can ask complex questions that they couldn't figure out by themselves or they couldn't get answered in the forum. Here you see one of our webinars where Carlos is explaining teachers how to program small games with processing. So this is about the programming part. In total, our package includes 10 different webinars for the teachers to attend that you could adjust to your own pace. So if you run this class in 3 months, then you can have them with less time between webinars. If you run it in 6 months, you can have more time between webinars. We schedule webinars every other week. And at the end of this whole process, you come to a science fair where the teachers and the students come together and they show their results. This is an example of one of our fairs that we've been running around the world in the last years. In this case, we partnered with the Cosmocais Museum in Barcelona, and 1,200 kids came together from 75 schools to present 200 more or less projects. We typically show up with a camera and a microphone and we interview them and ask them, oh, tell me, what was cool about this project? What did you learn? What didn't you learn? So here you can see I had a bit less gray hair, but these are different projects that the students built. I will just present you my favorites. Actually, my absolute favorite comes very soon. I'm a book addict. I read a lot of books. So these kids are going to show up now. They made a library handling system where you choose in your computer the book that you're looking for, and a laser beam tells you where it's on the bookshelf. That's my absolute favorite. You know, I have a gigantic bookshelf with books ordered by color, so I have no idea where they are. So there are more simple projects, like these people, they made a small piano. These guys, they made a soap bubble blower machine. You know, we try not to limit the kids' creativity. So they spend some weeks trying to figure out how to solve the project they want to build. And we help them through our online platform, through support calls, and through our forum in finding out the right things. We don't solve it for them. We just give them the hints of where to find the right documentation, how to make it. I mean, you can even interacting with 15,000 students is not easy. So, yeah, I'm going to show you some demos. And typically, I would just stand here and assemble everything, but when I came, I realized how small the booth was. I realized I couldn't do it. I've been a table and a whole lot of other stuff, and so I prepared everything on video. I'm going to show you one of our funniest projects called Binary LP. As I said, there is 26 construction projects in this. The students that will not make the 26, it will take them probably 4 full years of class to make all the 26 projects. So this project, what you can expect to do is to build a small long play player where you can draw yourself the music you want to listen. And what you learn here is how to count in binary. So with these 3 lines, you can write different notes where the black signifies the 1 and the Y signifies the 0. And what we have here is a line following sensor that is typically used for robots that follow a line. So we are actually disrupting the idea on how to use sensors used for robotics into do something else, which is very important for us. And when you use it, well, first thing, you need to build it. The whole building process is calculated to take about 45 minutes. Here we speed it up to 1.5 minutes. But the idea is that each one of the construction blocks, each one of the programming events in this course are programmed to last exactly one class. And one class nowadays, they last about 45 minutes. So after building it, the basic thing you can do is this. So you can write your own song. If you are Mexican, you will be listening to a funny song. Since you are not Mexican, I think, then you don't recognize it. It's okay. But then, as I said, the Arduino 101 board has extra features that other boards don't have, which is, for example, Bluetooth Low Energy. So you can actually push it a bit further and include an application and communicate to this toy through Bluetooth. This is actually for the kids that want to go beyond the normal level. And then you can play with it from the phone. I know it's cool. I also like it. I actually programmed the application for you people. So if you get it, it comes in the package. I want to show you another example, which is it's a bit closer to the classic robotics experiments. You know, make a robot that you can remotely control from a mobile phone. You know, it's a classic one. This is a classic example where you connect software and hardware, you use the sensors on the board, and you learn a bit about other things. Here's how you build it. I think the computer is not catching up. In my screen, it goes a lot faster. Okay, now. And once you have it, you can interact with it. So the idea behind this project is, again, play around with wireless communication, learn about how you use Bluetooth in code, how you receive commands, and how you execute actions based on those commands. This is just one of the 26 examples that come in the kit. So as I told you earlier, we've been trying this thing with a lot of people. And you will say, with how many people? Well, we tried this out at 536 schools exactly right now. On the 17th of February, if you happen to be in Barcelona, we will make another science fair like the one you saw in the video at Cosmo Caixa. It's a Friday. So you're more than welcome to come and see what the students are bringing this time. We've been working with 15,000 students. We documented over 1,000 projects. We have had 10 science fairs. And I think this is the most relevant part. Because I didn't really went into the aspect of, like, in my opinion, technology teachers should know how to deal with digital technology. And this means, in the longer run, to learn in a way or another how to program. Well, 69% of the teachers that use our system until now, they learned how to program while they were interacting with this system. So they didn't know how to program before they started, which is very interesting to know. And you can see the satisfaction index that we have measured. More or less everybody are very satisfied. And you will say, and this is the sales pitch people, can you get this now? Of course you can. So you can just go to the Arduino website and purchase it today. And if you want to see more details about it, you can both visit the Intel booth or partner in our own booth to get to find more about it. So thank you very much, and I open the floor for questions. Any questions?
If you bought the kit and you had in the technology department, say like a CNC router, could you make some more kind of devices to go with your Arduino technology?
So the question is whether it's expandable.
Yeah.
Yeah, totally. These are completely standard parts. in our Arduino catalog. The only things that are a bit special are the laser cut pieces and the line following sensor, because that didn't exist in the market and we designed it specifically for this. But every single part in this kit is completely standard parts you can buy already now. So if, let's say, you wanted to have 7 groups instead of 6, you could buy the missing parts and add them to the kit and continue to work with it. Yeah.
Do you have a hands-on experience here at Bett, so you can fit over and try some of the projects?
Yeah, we have, I think, 8 or 7 projects down at our booth. You can totally go there and try them out. Yeah.
Hello. Was the mobile app already built, or can you modify the mobile app by students?
Yeah. Well, the mobile apps, they are made in Android, the ones you saw here, but they are open source, so you can just get them and change them. Yeah.
Might be a bit obvious, but are they very reusable? So once they've made the project, you break it up and then reuse it for someone else's?
Yeah.
Is that correct?
Yeah, the idea is that, because we try to push the price down, so we started working with this project with foundations that were saying, look, the problem we have is that we don't have 10,000 euros to spend in every school. So we looked at reusability of everything that you mount, you can easily dismount, and also the idea that every group makes a different thing that also allows you to continue the education further if you want to, and you might be considering like, okay, I use the first block for over 6 months and I expand my education for 2 years, for example. Because you can just get the kids to circulate among the kids. So it's expandable in the both directions, time and space kind of thing. Okay, if there's no more questions, I will encourage you to visit our booth. Thank you very much, and I will see you in the future. Thank you.